Hi, hello friends. Welcome to the today's session. Welcome to Unacademy. Welcome to Srinivasarao Sir classes. So in this session, we are going to cover distance vector routing because last session I already covered routing and types of routing and how autonomous system is going to exist and how your ISP is going to exist and how it is being hierarchically divided. I have shown you in the last class. In this session, we are going to see one of the intra-domain routing protocol that is called intra-domain routing algorithm that is called distance vector. Because why I am saying it is intra-domain means intra-domain there are two protocols like RIP and OSPF. RIP is based on your distance vector only. That's why first we are going to learn distance vector routing. It is a dynamic algorithm and adaptive algorithm. So what is that and what is its importance, we will see in this session. Before entering into the session, let us say all our anthem that crack GATE and ESE with India's largest learning platform, none other than Unacademy. Get Plus subscription and access unlimited live and recorded lectures from India's topmost educators. And my dear friends, we all know Unacademy has brought forward a wonderful digital content which are for dedicated students by the dedicated faculty members. So we know that you can easily crack your examinations or PSUs or campus interviews. Well, my dear friends, myself is Srinivasarao IS, having more than 15 years of experience in the GATE with various subjects. I also had industry experience in the back-end side, that is the database networking. My dear friends, also had a very good certifications in the respective fields. Throughout journey of GATE, I taught in many premium academies with a high success rate. So many of my students settled in their topmost positions in the topmost companies. Some are in PSUs, some are in topmost companies. This is all because just they have completed their post graduation from India's topmost institutions, IT, NIT, Central Universities, and IIITs. You also can achieve that just by clearing GATE examination with a good rank. So that guidance and coaching tips and shortcuts are provided by Unacademy. So you please immediately get the admission into Unacademy and get the benefit out of it, because once you become a subscriber, then you are going to get live sessions like quizzes, dedicated quizzes and mock sessions. Many other things are going to happen. Along with that, counseling and guidance also is going to be given. So there are two types of courses. One is a plus, the other one iconic. So iconic batch is a 1:1 personal coach program which inbuilt is having plus course only. So the subscription prices of your plus course is, so like this, by using my referral code, then you are going to get a maximized discount on this. So use my referral code, enjoy the benefit, discounted benefit on your subscription. So fourth year and third year and second year and first year student, those who want to opt for long-term coaching, that is very good, because multiple number of times you can able to have the lectures. So use a 24 months or 18 months subscription, but if you want, you can also take a 1 year subscription. Once you apply my referral code, then you are going to get the prices like this. My referral code is eligible for any kind of a course, not only for GATE ESE, my dear friends. And when you talk iconic batch, it's a 1:1 personal coach and guidance. So inbuilt you are having a plus course in that. So use my referral code to get the maximize the discount benefit. So by applying my referral code, you are going to get iconic batch subscription like this. My dear friends, still if you are having any doubt, please feel to ask your queries by filling this form, and we are going to come and clarify all your doubts. And Let's Crack GATE CSE is our YouTube channel. Subscribe our YouTube channel, hit the bell icon for latest notifications and updates. I use my referral code to get the admission into Unacademy. So therefore, you will be joined under me. Then I can be your guide so that I can able to give your career guidance also. So let us start. What is the distance vector routing algorithm? Before entering into the session, last session I gave you few important things. So what the routing? Routing is going to provide an optimal path. It is one of the delivery mechanism. So there are three. Network layer has got three delivery mechanism. One is delivering the packet, forwarding the packet, and routing the packet. So routing in addition is going to give you, apart from forwarding and delivering, it is going to take optimality principle. That's the meaning of routing. So who is going to perform a routing? Naturally, router. Now the router is going to implement routing protocols to perform the routing. So there are few famous routing protocols I have shared yesterday. That is intra-domain interior routing. The other one exterior routing, which is inter-domain. Intra-domain routing, the famous protocols are RIP and OSPF. Inter-domain, the famous protocol is your EGP, that is replaced by BGP. Right now, the industry and your IP protocol internet layer is following OSPF and border gateway protocol, in special that path vector. Okay. Now you want to run the protocol, there is a requirement of some software mechanism technique is required. Therefore, so to perform intra-domain and inter-domain, there is a requirement of routing algorithms. So last session I have shared two varieties of routing algorithm, non-adaptive and adaptive. So under non-adaptive, it is a session routing, also called as a session routing. Predefined path is established. One of the algorithm is shortest path and flooding. And when you talk the adaptive, then you are going to have distance vector and link state routing and hierarchical routing, broadcast routing, multicast routing, many other are there. But the famous protocol, famous routing algorithm among all of them, shortest path, flooding, and the very important algorithm in real time is a distance vector. It is one of the powerful algorithm because it is a dynamic which is going to provide a extraordinary optimal paths and a very fast calculation also. When provided that your router is supposed to be very faster. If it is a dead router or a slow router, a distance vector cannot be used because it is involved many more calculations. That's why we prefer in such case, if you are having a slow router or a dead routers, then better you follow link state algorithm, right? So I have already shown you OSPF is depends on a link state algorithm. RIP is depends on OSPF. So RIP is based on distance vector. Right, your path vector is following a distance vector and EGP is following link state. Okay, so this is what we discussed in the last session. Now this session I want to reveal the power of distance vector and how you can able to calculate the routing table. And you may get a doubt that what is a routing table? A routing table is nothing but what? Which mainly consists of routing entries or rows, routing entries or routing records or routing rows, which mainly consist of source address and destination address, next hop address, and how much is the cost. These are the four varieties we primarily see in the routing table. So which consist of different routing addresses, source address, destination. They are going to be changed time to time. Okay. So this is your a table which consists of routing entries. Every routing entry, for example, I say source is a 1, destination is a 2, hops are 3, cost is a 3. Next hop I want to write as R3 and cost is a 3. Now again source address is a 1, destination address is a 2, there is other way also hop, and I say that cost is 2. So my optimal path is this only. This is your optimal path. Okay. This is a routing table. Now let us see a distance vector, how it is going to construct a routing tables. I will tell you a process and also I will tell you a shortcut. Whichever you want to follow, you follow. Shortcut is the best preferable, which will give you exact answer as like your procedure. Procedure takes a lot much time to construct routing tables. Because a distance vector periodically try to construct the routing tables whenever there is some topological significance or topological change or delays change. It is designed by Bellman Ford, implemented by Ford and Fulkerson. It was our ARPANET routing algorithm. Nowadays we are using in internet in the name of routing information protocol. What is the power? What are the features of distance vector? It is completely depends upon vectors distance only. That's why it is called as a vector routing or distance vector routing. It's completely depends on neighbors distance. Okay, and it is going to support all kinds of metric measurements like hop count, queue length, and distance, and transmission delay. So what are the other names of distance vector routing? It is a dynamic, because every packet it is trying to calculate what shortest path every time. Like a Google map is one of the example I shared in the last session. It is also known as iterative algorithm. What is iterative algorithm? Construction of routing algorithm is iterative process unless and until your routers are stabilized with the proper values or proper routing entries. Because the output vector table is given as input to other particular routers for their calculation. So that's why it is a iterative process. It is also known as a distributed algorithm because routing tables are distributed across the network. It is also known as asynchronous algorithm because routing values are given at different intervals. That's why it is asynchronous. So what are the metrics supported by distance vector? All metric measurements it supports, like hop count and distance, how many packets are queued in the length, and the transmission delay. So what is the process of distance vector? Please observe. So 4 to 5 important steps are there to construct your routing tables as a process. That's what Bellman Ford algorithm. And I will also give you a shortcut to do that. Let us see the first step. And I will tell you first in diagrammatical way. There is a router 1 and there is a router 2 and router 3 and router 4. So 4 routers are there. and this is how it is been constructed. It is 3, it is 2, it is a 5, it is a 7. Now for example, R1 neighbors. If at all everybody is a neighbor in the network, no problem. There is no use of what? Routing algorithm. Routing algorithm is only known because you cannot have all the branches your neighbors only. There are some non-neighbors or non-vectors are also available. So we want to find non-vectors distance. That is the concept of routing algorithm, right? So I want to show you like this. See, sender is connected to network 1 and this receiver is connected to some other network. And now this and this is connected with many intermediate routers. You cannot guess how many are there, right? Now sender can directly transmit the data to R1. It's a direct delivery. And receiver can receive the data directly. It is a direct delivery. Yesterday, last session, I have shown you this. Sender to R1 is a direct delivery. And last router 4 to receiver is a direct delivery. But in the network, I don't know what is happening. It's completely indirect delivery only. It's indirect delivery. Now you decide, understand that R3 and R5 are not my neighbors. My neighbor is only R1. Naturally, in a network, 1 or 2 may be your neighbors, remaining all are your non-vectors only. Our task is to find data, our task is to transmit the data to other non-vectors also. If everybody is your vector, no problem. There is no requirement of any kind of routing. Whenever you are having a non-vectors, we want to find a what? A shortest path to them. That's what the meaning of routing importance. Non-vectors, we want to transmit the data. Okay. So according to this example, R1 neighbors are R2 and R3. Two vectors are there. But R4 I don't know. So R1 to R4 I don't know. Because R4 is not my neighbor or not my vector. It may be vector to some other node. Therefore, our intention is to find a value to R4 also. Because distance vector requires a complete knowledge of your entire subnetwork. So if at all there is a partial routing table is there, it cannot able to give you any shortest path. So this is one of the major drawback of your distance vector. Every node which is there in your network is supposed to know about all other routers which are there in your network. Directly or indirectly you need to know about their distance and metric measurements. That means every router within the network must know knowledge about all other routers which are there in your particular. That's why it is taking a much more time complexity. Order of n cube, I can say. It is n into n minus 1 by 2. That's what the time complexity of your Bellman form. So what is the process? So whenever a packet comes to a source router, please understand. For example, this is the source. Packet 1 has come. I want to transmit this packet 1 to router 2 and router 3. As simple, because they are my neighbors, I just push them. But I also want to transmit my packet to R4, then it's not possible. So now you want to find what is the value to R4. I am depending on my neighbors. What are my neighbors of R1, R2 and R3? I am depending. So R2 table will give to R1 and R3 table also will give to R1. Then R1 find the value to or distance to R4 with the help of R2 and R3. That's why whenever a packet arrives to a router, if it is a vector, you directly transfer. If it is a non-vector, you ask your vectors to give your routing table so that the source will find a value to non-vector. Right? That is the first step. Whenever a packet comes to a source router, if it is a vector, destination, no problem, you can assign it. If it is a non-vector destination, then the neighboring routers will give their routing tables. Based on those routing tables, now a new routing table will be created using the vector tables and forward the data. So vectors will give you vector tables to you, and you are going to find a new routing table, a new distance or length to your non-vector. Right? It is a dynamic because it takes the help of next router for routing the packet. Indirect delivery it is. Every node is nothing but a vector only. Every node shares its routing table with its immediate neighbors. Periodically, it's called a triggered update. It's called as what? Triggered update. Whenever there is update, immediately it will share. Whenever there is update, immediately it share that I got changed, I got updated, I got updated. This is called a triggered update. Please observe carefully. Triggered update. Periodical changes are nothing but triggered updates only. So what are the problems of drawback of distance vector? It is not suitable for deadlines or slow transmission lines or dead routers. You need to have a faster, very fast, like a Cisco router is using your distance vector only. Your Cisco routers are using RIP, routing information protocol. Whenever I say routing information protocol, it is indirectly using distance vector only. Your wireless routers are also, Linksys wireless router is also following RIP only, distance vector routing. So it's a pretty expansive. Why? You need to find edges. Please understand carefully. R1, R2, R3, R4. So R1 is supposed to know about n minus 1 nodes. So that's why n into n minus 1 by 2. Why by 2? Because it is what? Bidirectional. Both sides, it is a bidirectional. It's not unidirectional. Right? It is a bidirectional graph. Therefore, every node must know about all other n minus 1 distances. Right? And you need to know for every vector. That's why it is n into n minus 1 by n into n minus 1 by 2, which is order of n cube. And the other problem is that count to infinity is a major problem with your distance vector. Count to infinity, which is going to form cycles. So you're going to record the false values instead of recording a true values. This is one of the problems. And too much long convergence while constructing of routing tables. But it's a very fast actually it's a very fast conversation. But in the event of count to infinity, it automatically becomes slow. Its capacity is going to be reduced. Its advantages is very faster. I will write its advantages. What's its advantages? Very fast. Fast convergence. Or you can also say that another advantage is that accurate shortest path. It's a perfect dynamic routing algorithm. What are the rules? Rules for constructing your vector tables. First one, source will construct partial tables. Every node is acting as its source only. Every node, I am the source, I want to transmit the data to other. Therefore, every node is going to find n into n minus 1 by 2. And it is happening at every vector. That's the meaning of n into n minus 1 by 2. So every source is going to find a partial routing table. So why I named as a partial routing tables? Because Some are my neighbors, some are not my neighbors. I don't know about my neighbors initially. That's why your routing table is going to be partial. Please understand. You know up to about your neighbors, but I don't know about your remaining non-vectors. So you need to find a non-vectors values from your neighbors routing table. Second point, whenever a packet arrives, then source asks your vectors to provide your routing tables so that I am going to calculate what? A new routing table from source to non-vectors with the help of vectors. Please understand. R1, R2, R3, R4. If I give a direction like this, what is the meaning of that? R1, if I am saying that I am the source and the sender sends the data to R1, R1 is going to give you routing path. How? R1 knows that R2 and R3 are my neighbors only, my vectors, but R1 do not know about R4. That's why your routing table is initially partially completed only with your neighbors only. Then we will extend our values to non-vector values we are going to extend with the help of vector routing tables, because this is your R4 is a non-vector to R1, but R4 is a vector to R2. Please understand carefully. According to this diagram, R2 comma R3 are vectors to R1, but not R4. But R4 may be the vector to somebody intermediate node. Therefore, I can confirm here that R4 is a vector to R2. Therefore, what I do, I will ask R2, give you a routing table, because you know knowledge about R4. Therefore, R1 is going to calculate the distance to R4 or learning about R4, right? And the second rule, source is going to copy its old routing table into a buffer, because you are going to construct a new routing table. Why it has to be maintained in the buffer? You may get it out. If new routing table values and old routing table values are same, then we don't take new routing values. We are using our old routing table only. That's why you need to maintain old table also. And if at all you find any new entries in your new routing table, then we will copy those entries into your old routing table, right? So source node copy your old vector table in the buffer, and the source node add its link cost to those entries. Then merge the new table if at all you find a new values, otherwise you keep old table only. So this process continues with all the vectors till routers are stabilized. So what is the meaning of stabilized? Even you go for n number of iteration, you are not going to find the new values, you are getting same values only. That is the meaning of what stabilizing. A stable point. Even you try to calculate some other iteration, then you see that the values are coming as like your previous iteration only. So you can stop your process. So till your routers are stabilized, you need to process them. Okay. So I'm going to give you an example. Observe carefully. He is asking construct routing tables for a given subnet using distance vector. Okay. First, I will calculate partial tables. Partial tables means what? Up to neighbors only. Then I will complete it using vectors tables to find the non-vectors distance. First, let us write partial tables. Partial routing tables. What is a partial routing tables? Up to vectors only. Up to vectors, we find length or distance or cost of path. First I am taking A routing table I am taking. Your routing table has got mainly source address, destination address, next hop, and cost of the path. So 4 entries I am taking. Source address and destination address and next hop and cost. Okay. So destination I will write here only instead of mixing there. This is my source. A is my source. And the remaining are going to be our destinations. What are your destinations? A to A, it's a 0 always. A to B, and we are going to find. This is a one entry. A to B I am finding. This is your source. And next destination is B. Next destination is C. Next destination is D. Next destination is E. Observe, every node supposed to find or every node supposed to have a knowledge about all other routers. Okay. So a router itself is always 0. Please observe. A to A is always 0. A to B we understand. Can I find A to B? Yes. B is your neighbor. How much? 5 is the cost. A to C can you find? Yes. 2 is the cost. Can you find A to D? No. Yes. A to D is also my vector. 3. Can you find A to E? No. I don't. Clear? So A to B cost is a 5. A to C cost is a 2. A to D cost is a 3. A to E it is a not yet defined because it is your non-vector. This is your non-vector. I am going to find a partial routing tables only up to vectors only. This is about A. And what about B? So B to A, B, C, D and E. So B to B is always 0. What is your next hop? B only. So you want me to write next hops, I will write. A immediate next hop is B and your next hop is C and next hop is D. I don't know about E. And B to A, how much? B is a B to A, that means A is a B's neighbor. Bidirectional it is. So cost is 5. My next hop is A. And B to C, can I find B to C? Obviously, it is a 4. And C is my next hop. Can I find B to D? Not possible because D is not your direct neighbor, right? So leave it. Can I find B to E? Yes, because E is a neighbor to that. E is my next hop. Here NH is nothing but next hop only. This is your source, they are your destinations. Okay. Now listen. So this is your non-vector. I am unable to find its value. Next you find a C router. Partial routing table I am constructing. So A, B, C, D, E, C2, C0. Let us see. Your next hop is C itself only. So C2A, yes, it's a direct neighbor 2. My next hop is A only. C2B, yes, 4. My next hop is B. C2D, possible? Not possible, because it's a not a non, it's a non-vector. C2E, can I find C2E? Yes, obviously. So 4 is the cost. E is the next one. So we also find a routing table for D. And do routing table is source and destination. They are D to A. What are the vectors of D? First I am writing vectors only. D to A. Yes, it is a vector. And D do not have any kind of vectors. Observe carefully. D has got only vector to A. Remaining are not vectors to anyone. So D to A, what is the value? It's 3. And remaining I don't know. I need to find. And what about E? E is routing table. It is also A, B, C, D, E. So E to E is 0. E to A. E neighbors, we want to identify E neighbors. E neighbors are B and C only. 3 and 4. So that's it, my dear friends. We have completed partial tables so far. Now we want to complete these partial tables with the help of what? Vectors to fulfill or to fill the entries of non-vectors. Observe carefully. This is your non-vector. 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 Every routing table has got fewer non-vectors. So with the help of other routing tables, we are going to find what? These non-vectors value. First, let us complete A's routing table. Because A is partially completed. A needs still E, only one non-vector only there. And B also only one non-vector is there. So A and B tables we are going to solve. So A routing table updating. Which is nothing but finding distance to non-vector. Finding cost to non-vector. Using vectors knowledge. So this is our task. First A table I am taking. What is your A table? Your A previous table. I know everyone except E. E only I am unable to know. So A to E you want in the sense, please come to the diagram. A to E you want in the sense, so A to B is your vector and from B I can go to the E, or A to C is your vector, from C you can go to E, right? So which is the shorter among them? So they are the direct neighbors. E is the direct neighbor to B as well as C, and B and C are the direct neighbors to A. So the shorter one is 2. I am taking 2 now. That means A to C path I am going to use. A to C path in the sense A will request C. A request C, not only C, it can also request other neighbor also, no problem. But time taking, that's why I'm taking directly A to C. A request C for C's routing table. Okay. So this is your existing table of A. What is your existing table of your A? It is 523 0 5 2 3 nothing. And your next hops are A, B, C, D, nothing. This is your existing table, right? So this I kept in the buffer because your existing table must be kept in the buffer. I will check that any other new entries are there. If entry, I will merge that. And next step is, so A request C for C routing table. It is ready to give you. Now A to C cost also you need to take. A to C cost. That is important for us. What is A to C cost? Look at the diagram. A to C cost is 2. Or you can also look at the routing table. A to C cost is 2. Okay. Now C routing table we are going to get it. What is C routing table? C table. Your C table is 240 240 null 4. Okay. Now listen carefully. Take this cost 2, add it to this, plus 2 plus 2 plus 2 and plus 2 and plus 2. After adding, you got one value. What is the value? It is a 2, then 6, then 2, then 6, 2. And 6. So can we able to place here? You want to place means these values must be lesser than to your existing table. That's very, very important. So these are the values for where C2AB, C2B, C2C, C2D, C2E, right? You're asking for which value? Only C2E only I'm asking. Otherwise you want to compare, you can compare. So C2A, what is the value? It is 2. Yes, I got 2. Remaining I don't need. So our main intention is to get the value of this. I got 6. So get this value. Update your existing table. 6. What is your next hop? You are going to E. How you are going to E? Please look at. A goes to E via C. That is your next hop. A next hop is C. So you completed. So you want me to do another style, you can also do. What is that? You take other neighbor of your A. What is your other neighbor of A? Your other neighbor of A is B. What is the cost? 5. So you add this 5 to your B routing table. What is your B routing table? Just come here. This is your B routing table. So 5 plus 3, 8. If I add, it is going to be 8. But how much I got? Please listen. How much I got? I got 6. 6 is lesser than 2 others. That's why I chosen 6 only. Okay. So A table is got completed. Now let us update B table. Updation of B table. Because B table is also partial. So B existing table is in. You have to keep it in buffer B existing table. So what is your B existing table? It is 504 null 3. 504 null 3. Right? And now you are going to find about this value. This is your non-vector. We are going to find about this value. Let us see. B is asking neighbors to give your tables. What are B neighbors? Observe carefully. B neighbors are A, C, E. So which is having a lesser cost and which is having a link to D. That's very, very important. Which is having a link to D. Come to the diagram. If I see that B is having a neighbor C and C cannot directly go to D. So it is going to A and from A it is coming. Therefore, B neighbor is E. E do not have any link to D. Please understand. That's why you cannot use this neighbor. You cannot use this neighbor. Even use it is going to be very long. B to E, E to C, C to A and A to D. Instead of that, I have got B to A to D. There is a link. That's why I am taking only B to A link. So remaining I am not going to take remaining routers or remaining neighbors. So B to A I am taking. That means it is asking A B request for A routing table. So already A routing table is updated very recently. You take that recent updated table only. Okay. Every change immediately shared to the neighbor. So A routing table I am taking. It is 05236. 05236. A, B, C, D and E. This is your A routing table. Now I said take a cost from B to A. What is the cost of B to A? From the diagram, B to A cost is 5. So take that cost also. B to A cost is 5. Add this 5 here. That's it. You got a value. How much it is? 8. So fill it. Update this value here. Now I am completing B table 8. What is your next hop? Here your hops are same except this. What is your next hop? I am taking help of A. Your next hop is A here. Okay, B table got completed. So we want C table updation. Updation of C table. So you want updation of C table, you take existing C table. What is existing C table? Partial table I am getting. A, B, C, D, E. What are C tables? Your C table is 240 null 4. 240 null 4. Okay. Now your next hops you know. It's a direct. Now this is your non-vector. You need to trace out the value of D. So you see that which of the particular vector has got a link with D. So first let us find C's neighbors. What are C's neighbors? They are all your C's neighbors only. Come to the subnet. C neighbor is A and C neighbor is B and C neighbor is E. C is asking for what? D. But D is not a neighbor to C, but D is a neighbor to A, not E, not B. Therefore, C depends on A only. Right? So C to A. IT again C is asking A routing table only. C is asking C request for A's routing table. Don't worry, I will give you a shortcut. So A table we are going to take. What is your A table? The very latest one. Your A routing table is this one 05236. And you need to take the cost from C to A. What is C to A cost? It is 2, I think so. Yes. So add this 2 here. So you're asking for which value? D value only. What is the value? 5. So post this 5. And you are depending on A. Your next hop is A1. So C table also got updated. So likewise D table you need to update. So you can carry on this D and E tables. Updation of D table. So first you keep your D table. So what is your D table? 3 null null 0 null. So nothing is there. So A, B, C, D, E. I have got only one vector only directly. So now as you are having only one vector, you depend on your vector, find the values of other non-vectors. They are all your non-vectors. Okay. Then D asks for A's table. Once again. What is A table? Already we got it. 05236. What is the cost? Cost of D to A. D to A cost is 3. Add this. That's it. You got the values. What is the value? It is 8. A is the hop. It is 5. A is the hop. It is 9. A is the hop. That's it. So there is a shortcut. I will tell you about this. What is the shortcut? Come to our direct subnet only. So I am doing directly from here, right? So I am finding A table. First write your vectors directly. A vectors we know. A, B, C, D, E. So A to A value 0, A to B 5, A to C 2 and 3 we don't know this value, right? Now this is a partial table. We want to find a value of this. I will give you a shortcut. Instead of doing such a long process, I am releasing a shortcut C. Anyhow, you are asking your vectors to share your tables now, right? A vectors, let us see. A can go to E via 3 vectors. What are 3 vectors? A to B, and from B I can go to E. A to C, from C I can go to E. A to D, from there I can go to E. Whatever process I did, I am doing in a shortcut way. Tell me A to B, what is the value? 5. Tell me what is the A to C value? It is a 2. Tell me A to D value. What is A to D value? It is a 3. So B to E how much? Come to the graph. B to E how much? 3. C to E how much? C to E, it's a 4. And D to E how much? There is no link directly D to E. That's why let us find a D table also. So D can go to A and A to B and B to E. Like this you can go. So let us find a D table now because I need D table. So A, B, C, D, E. What is a D table? D to D is 0. D to A is 3. And remaining I don't know. So D to E we want. So how are you going to go to D to E? Let us find. D can go to E via D to A and again A to B and B to E. What is the shortest? D to A is a 3 and A to B is a 5. 3 plus 5, 8 and B to E is a 11. So D can go to E with 11 cost. Otherwise, D to A 3, A to C 2 and C to E 4. How much it is? 9. So if you go this side it is a 9. If you go this side it is a 9. If you go this side it is 11. One more way is also there. 3 to 3 plus 2 5, 5 plus 4 9, 9 plus 3 12. So it is going to be very high. So we are preferring this. What is that? D to A to C and C to E. It's almost all 9. So D to E is 9. That's it. We got D to E is 9. Now tell me 5 plus 3 is equal to 8. 2 plus 4 is equal to 6. 3 plus 9 is equal to 12. You need to take the shorter always. What is the shorter here? 6 is the shorter. That's it. You got your value. 6 is the shorter. A is going to E via C. This is your next hop. Okay. Now B table also I can able to find like this. What is your B table? Let us do in next page. B table. So rest you can continue like that. A, B, C, D, E. B to B 0. Let us see the subnet. B to A. B to A it is a 5. B to C 4. And B to D how much? No. B to E how much? 3. So we want to find this value only. How can you find this value? I told you. B can go to D using its neighbors. Who are its neighbors? A is my neighbor. According to this, already I know the values of your neighbors, right? And according to C I can go. According to E I can go. So B to A value is a 5. B to C value is a 4. B to E value is a 3. Now A to D how much? Come to A table. A to D it is a 3. And B to C and C to D. C to D value, what is the C to D? Come to C table. So C to D. So you see if you can go like this, its value is 5. That is only shorter. Always we prefer shorter only. So C to D is a 5. And E to D, already just recently we constructed E to D. E to D. What is E to D? So E can go to D like this, or E can go to like this, E to C and C to A like this. What is the value? It's 9. So it's 9. So post that value also there. Now let us plus them. It is a 8, it is a 9 and it is a 12. So shorter one is this only. So post 8. So what is your next hop? B can go to D via A. This is our next hop. Okay, this is about B table. So B to D is 8. So here in the process also we got B to D 8 only. So shortcut you please prepare always. Now we want to find C table. So after this you continue remaining. So C vectors tell me what are the C vectors according to the diagram. C vectors A, B, E. So 3 are C vectors. So C2A 2, C2B 4, C2C 0, C2D not there, C2E is there, C2D not there because it's a non-neighbor, C2E is there 4. Now tell me C can reach to D via A and B and E. So 3 paths are there. Their distance also there 2 and 4 and 4. A to D how much, B to D how much, E to D is how much. Come to A table. What is A to D? Your A to D value is 3. What is B to D? Come to B table. 8. Recently we calculated. What is E to D? We recently calculated E to D. It's a 9. So sum them and see the shorter one. So this is a 5, this is a 12 and this is a 13. We take the shorter one. What's the value? 5. What is your next hop? C can go to D via A. Okay. Now last D table we will do it. So D do not have any kind of neighbors except A. It's a 0 and D to A it is a 3 and these values I need to find. How to find? D can go to B via its neighbor, only one neighbor only. So D to A how much? What is D to A? Already D table we did. D to A is 3 and A to B how much? 5. D to A and A to B it is 8. So you will write answer as a what? 8. Again next one. D can reach to C via A only. D to A and A to C. What is the D to A? 3. And A to C. What is the A to C? A to C is a 2. So take that 2. So it is a 5. So post it there. So your next hop is A only for all of them. Next D can reach to E via A only. D to A 3, A to E is a 6, it is a 9. Post it. That's it. What is your D routing table? 38509. 38509. Look at this. 38509. So in the process also you got same. In the shortcut also you got the same. So better you prefer always shortcut. So 38509. That's it, my dear friends. Thank you for sparing your valuable time. Please follow my lectures. Please do them. Do like them. Share your knowledge. Share these lectures to all your friends. And to get many more content with a lot much depth learning, use my referral code to get the admission into Unacademy. So stay tuned to Unacademy. Stay tuned to Srinivasarao Sir classes. That's my classes. Thank you very much.